What's up, everybody? Welcome back. Today we are working on our map app, which is an attempt to replace Google Maps with something that can plan my trips around the city a little better. And today's topic is trying to monitor real-time transit data. So the idea here is that I go to Google Maps and I say I want to go from one place to another place, and I'm going to take the bus there because I don't drive because I'm too lazy to get my driver's license or something. Whatever. I don't know. I'm gonna get on the bus for whatever reason, right? And he says take 3 transfers and you're gonna take a bus that goes like 4 blocks. And I'm like, oh, dude, like I'd rather just walk the 4 blocks and not worry about the transfer. Like, what are you doing? And so I'm like confident that there are attributes of bus planning that Google is making like some sort of trade-offs, right? He's trying to say like, well, you probably don't want to walk. You probably want like the fastest route. You're willing to like change your schedule around when the buses are going to leave. And I'm like, no. I want something where I'm going to get like a consistent route that's relatively fast. I don't care about walking. And there's stuff like that. I'm willing to make trade-offs that the Google Maps algorithm is not. And so I'm like thinking about that. I'm like, well, why don't we just make an algorithm that does what we want, and let's expose all of the knobs that we're turning to get what we want, and we can have like a very heavily customizable path planner. That's kind of like the plan. What you're seeing right now is like our first attempt at bus planning, right? So if I look here, we can kind of see all of the nodes that we kind of looked at as part of our path planner. So you can see that we're doing some sort of like reasonably optimized A star that is kind of trending towards taking the bus when it can. But this route is maybe not ideal. Maybe I have to think about it a little more, but I think this isn't great. And something that like I really value here is the buses in my city will sometimes be late. They will sometimes be early. They will sometimes not come at all, right? And I want to build in information about that to the planner, right? I want to be able to like basically have like a consistency slider and say like lower risk, right? Like I don't care if it's going to take 5 minutes longer if the chance of me getting there when you say I will is like 95% higher, right? Like I'm way willing to take that. And so I want to look at the real-time transit data provided by TransLink and see if we can use that to kind of over time understand how likely it is that a bus will get there when it says it will. And so 2 days ago, last stream, we kind of like pulled in some data from TransLink's real-time stuff, and we can look at like, maybe we will look at what one of these looks like. Hold on, we need to get protobuf compiler available for us to look at this. But these messages come in these like protobuf messages, and last stream we implemented enough of a protobuf parser to be able to look at one of these messages, at least partially, to parse like the kind of top level structure. We didn't dive all the way down into like the deep dig, the like individual fields. We got some of them, but not all of them. And so we are at the place now where we should be able to pull out information that we want. We just have to figure out what information we want and what we want to do with it. So that's the plan for today. It's like find the relevant info, try to calculate like how early or late the bus is. Maybe that information is like provided to us already. We want to like maybe pull a server for this data over time and then like write it down in some way and probably set up some sort of like daemon. I don't know what you're supposed to say there. That will do that over a long period of time so that we can like process that data and get some sort of like high level statistics out of it later. So here is an example of a trip update, and I was kind of like skimming through the docs today before stream, and it looks like this delay field is kind of like the important piece of information here. So this, I think, is saying that we were 82 seconds early to this bus stop. And I think that these time fields, like these might be like predictions, is my understanding. So like, if I think we can see somewhere in here, we can see like where the time. What time is it right now here? And I think there was another time somewhere else I saw actually. Hold on. Let's see if we can find it. Entity ID, stop time update, stop ID. So this is, I think, the time that it thinks the bus will get there in Unix timestamp. And I thought I saw somewhere else that we keep track of like what time this was predicted at, but I don't see that anywhere. So we probably will use like this timestamp to say like this is the time that we got the request from. And then I think that we can look at this and we say like, is this before or after now? Right? And if it's before now, the spec says, it says in here that if it's behind, we should assume that it's unknown. But I believe there was some field in here that I was looking at that was talking about like uncertainty. Right here. So they talk about how like a trip update, they will tell us like where the buses are relative to where they're supposed to be. Updates can be for future predicted events or for past events. Normally, updates would get more precise and more certain as the events are get closer to the current time. But then they talk about how an update points to time in the past, but its update's uncertainty is not zero. The client should conclude that the update is a wrong prediction that the trip has not yet completed yet. Now, I was looking through the data that I got, and this uncertainty value is never there. So this says if uncertainty is omitted, it is interpreted as unknown. So unknown uncertainty. And then they were saying that somewhere else in here, I think it was maybe like trip update uncertainty. If an update points to the time in the past, but its uncertainty is not zero, then the client should conclude that it's wrong. Right. So we don't have uncertainty values. So based off of this spec, it's kind of saying that we should always assume that it's wrong. So I don't really know what we should do with that information, right? We might want to just take like the latest update we could possibly get for each time we pull the server for like the trip updates. We will probably get duplicate updates, maybe, right? If it's guessed like 2 minutes in the future, 5 minutes in the future, and then like that 5 minutes in the future becomes 3 minutes in the future, maybe we'll get like a more recent estimate for each bus. And so I think that probably we just look at this like delay parameter, take like the most recent for each trip each day, and use that would be my guess. We can maybe try that first, and we'll see if that feels like shit later. We'll see. We'll see. But yeah, that's kind of the plan. That's the plan. So I think we just kind of jump in, and we can kind of say that we were looking at the relevant info, but we can kind of say like extract relevant info is probably more what we want here. And we will start looking at this. Surely time of day is a factor for bus lateness. Yep. Those times look like actual absolute time. Yes. The times I believe were absolute times, and I believe that the delay is in seconds, but the time is absolute time. And so what we have trip IDs that are associated with each of these like updates. And so each trip ID, if I remember correctly, is unique for one day. So you have like a route, like the number 25 goes along 25th Street. And it's going to go along 25th Street like 20 times in a day or whatever the frequency is, right? And you have a unique trip for each of those ones. So we can probably correlate the info on like a per trip level, and that will give us some sort of like, we maybe after a month we'll have like a reasonable distribution of bus lateness at a given time for a given trip. That's kind of like my hope, but we will see. Okay, extractable minutes. So we're 8 minutes and 50 seconds in stream, and let's just try to pull out the information we care about. So I think that probably we want trip ID, almost certainly. We want delays for sure for each stop, for which stop we are looking at. I think likely we probably want to back up the entire protobuf that we get from the server, just so that if we decide that we want more data later, we can always go back through historical data and just rip it again. But maybe our database will not contain all that. Or maybe we instead of making a database, we just like write each of these requests into a file somewhere with its timestamp or something as its like file name. And then when we want to process the data, we just kind of like rip the original protobufs. That seems reasonable to me. Let's do it that way. Okay. So we have our our test app, which is capable of processing a feed header. And our feed header and a feed entity. If I remember correctly, we have a feed message here somewhere. Feed message right here. And he gets a bunch of feed entities, and the feed entities are, I think, where the interesting info is. So feed entity has trip updates, and the trip updates is the thing that we're looking at. So we have not started parsing this at all, so let's just kind of do that, I guess. I looked at like the vehicle position because I expected that that's where I was going to be looking, but I was wrong. That's not what I want. Okay. So our parse function is going to look similar to other parse functions. We're going to like make our protobuf parser. And then we are going to try to extract some information out of it. So let's try to just get one thing first. So trip update. Let's try to get, okay, trip descriptor is guaranteed to be required. So const trip descriptor. Trip descriptor is a struct. Now, other people, when they write these protobuf parsers, they actually like automatically generate code out of these protobuf descriptors. But I was too lazy to implement that, so we're doing it by hand, which is maybe shit, but whatever. So our trip descriptor, we're gonna try to just get the trip ID for now, and we will kind of figure out what other pieces we need later. So trip ID is field number 1. This is going to be at const u8, and if we get field number 1, we look at trip ID, and we try to get a string out of that. So it's just val data as buff. Boom. Otherwise, we got trip ID or trip descriptor field with something, and I guess we know that there's a lot of stuff that we don't handle, so we'll just kind of, maybe we'll make this a debug log. Too lazy to do it automatically. I mean, it is a lot of work, right? Like you'd have to write like a parser for the protobuf and then like generate the code from it. It's just like, it's not worth it, not worth it. Now you might say, why don't you do the right thing and implement this as a protobuf compiler plugin? And I would say, you're right. But we wanted to do it the fun way. And the fun way is to write it ourselves. So that's where we're at. All right, so trip ID should be parsed correctly here. And then here we just need our trip update. I think we said the trip descriptor came from trip update ID 1. So here we say descriptor. I guess it's called trip here, is a trip descriptor. And here we say trip is equal to trip descriptor parse of the buffer, and we say got trip update field with this ID, and then we say trip is equal to trip. All right, and if we did all of this correctly, we need to get the entity thing here. So this is trip. What was it? Trip update? Where does this come from? Trip update is field 3 here. So it's called trip update, which is a trip update, optional. And here we say, if we get 3, we say trip update is try trip update.parse. Chillin'. Chillin'. And then trip update is equal trip update. There we go. So now at the end, I guess we'll just start by like building this and see what happens. And we'll run this on like, oopsies, zig out bin pb test on trips 4 or something. He's mad that at 100 something, maybe I have to write return here. That seems likely. No field name trip at 119. That's true. And this also needs to be trip update, like this. All right. Found this, right, so I guess here, I think the trip update had a required field of trip descriptor. It was required, so this needs to be, oops, or else return no trip. Okay. So trip update field with ID 2. We also got an entity with ID 2. Entity with ID 2. So what is that? Field was entity. Feed entity is deleted. Whether this entity is to be deleted or not. So we are not handling that, but that's okay. We will ignore that for now. I'm okay with that. So we have a bunch of trip updates now, and it would be interesting to try to like look at them. So we can say like if we have a trip update, and if I guess the ID was required, so we can just print the dot trip update for, and then we put a string here that says the trip update dot trip ID. Ooh, so we actually, the trip I think was optional. I don't remember. Trip update, trip was required. Okay, so this is fine. This should be fine. All right, we have some trip updates for a bunch of trips. Good info, good info. And now we just have to, you know, pull out the pieces that we want from it. So route ID, I think we probably don't care about. Start time. Initially scheduled start time of this trip instance, blah, blah, blah. Can we just look at like the proto-C output? So we want this for sure. I don't think we care about any of this stuff. We do care about this though. So we want to look at each stop update. We want the stop sequence and delay. Yeah, I think that's right. I think that's right. So we want the, was it stop update? I already forgot. Stop time update. So this is field 2. Field 2 of the trip update. So here we want stop time update is equal to parsing a stop time update. Wow. And here we need var stop time update is a, I guess this says repeated here. So this is going to be an array, which means let's just take an allocator. And here we need to say this is a std array list of stop time updates initialized with our allocator. We need to defer freeing of that thing. This is between equals here. Stop time update doesn't exist yet, but we'll make it. Like this. All right. All right. And then here we need to store those stop time updates. So stop time updates is going to be a slice of stop time update, which means that here we're going to say stop time update is equal to stop time update to owned slice. Boom. Boom, boom, boom. All right. And now we just have to implement the parse function, which is going to look similar to our existing parse functions, except his insides are going to look a little different. He's got our stop sequence, optional, UN32. And we also wanted the stop time event. Maybe we'll look at both arrival and departure. All right, which means that we need a stop time event. And everything is optional here. So we want like delay is an optional I32. Time, and we know that uncertainty isn't available to us, so we're just gonna ignore it. All right, and so he again has a similar parse function, except it returns a stop time event. This does not have a trip or stop time. It's like var delay is an I32, time is an I32, time is an I64. Actually, I lied. And Okay, so delay is 1. And here, we actually need to implement signed varant parsing. We haven't done that yet, so we have to. That's going to need to be fixed. So for now, we're actually just going to do nothing for this. But we'll come back to it. So this now just gets delay is equal to delay and time is equal to time. Okay. Local variables never mutated. Fine. We'll write constant here for now, but we'll come back. This is chilling. Unused function parameter alloc. That's fair. There is no allocations needed here. And now we just need to make sure that we parse this correctly. So stop time update has arrival. So we have all of this stuff, I guess. Stop sequence is equal to U32 equals null. Arrival and departure are both stop time events. Boom, boom. We have the field of 1 is stop sequence. So we can get this is equal to val data as U32, which doesn't exist yet, but should be easy to implement. This should just have as U32. We'll check if it's a varant. If it's a varant, we have to try to kind of squish this varant into a U32. So we'll say like if stud mem, what is it? Math maybe cast from our varant into a U32, or else we'll return error varant too big. And that should do it. So we're chilling here. Stop time update. We have stop sequence as data as U32. And then we have 2 and 3 both get like arrival is equal to stop time event parse, and 3 is departure. Chillin'. This is not trip update, this is stop time update. And then we just kind of take all these guys. Oopsies, what the fuck did I just do? He didn't like it. These get dots in front of them, and this goes equals stop sequence. This is equals arrival, and this is equals departure. Chillin'. So he also doesn't allocate, which is fair. Stop time updates now. Were these parsed anywhere? Here we should have appended, so we should say stop time update dot append this shit because it's an array, not a single item. And then I think there's like a chance that this builds. Oh, we need to pass in our allocator here as well. Makes sense. Expected I64 down I32. That's true. No field name stop time update. Yeah, it is plural, which I feel like makes sense. Even though it's not plural in the protobuf, I'm okay with using an S instead. All right, so we have integer overflow at here, which is kind of interesting. To be honest. Let's look at that. So it's that protobuf parser here. So I guess what's happening here is we're trying to read a varant. These varants are structured so as like a way to kind of like compress big number into small bytes. So they do something where they're like, you know, if you say I have like a U64, you can represent this. They represent this as like chunks of 7 bits. So they say like, I have 8 bits in a byte, and I look at like the first bit, and this tells me whether or not there's more data after. Then I have like my actual data. And you keep going until you see a 0 here. Now, what we do is we like iterate and we say, well, there's a 1. We increment our shift by 7 because we're taking chunks of 7 bits, and then we're just kind of like ORing that shit into the value. Now, what is unaccounted for here is if we add to the shift and we get like the perfect amount of bytes. I don't know if that really makes sense, but if we get to like the last chunk of data, then this becomes like a fucking problem because this overflows. Because we say like you can only shift into a U64 by 63 or less or something. The maximum shift in a 64-bit int is 63. And so this is probably failing because of that. And so the question becomes, what do we do? What do we do in that scenario? What do we do? Well, there's also something weird here where like you definitely might need to shift by more than the max amount, right? Because if you have like, 7, you get like 7 bits, that's 14, 21, 28, 35, 43, 50, 57, right? If you want to get your 56, 49, I was off by 1, 42 instead of 43, 49, 56, 63. So if you want the 64th bit here, you need to kind of get like 1 bit here. So this shift needs to be able to represent more, which kind of makes sense. So calling this U7 seems reasonable to me. And then when we OR this stuff in, we kind of have to like intentionally truncate what we are ORing in. So we almost want to do this as like U128, then truncate this back to U64 after we shift. I guess the shift as a U64 is fine because it'll just shift stuff out. So this is fair. This is fair. And then we have to say, while this and oh, but this shift doesn't work. He doesn't allow us to like shift out the end. But I think there's like a shift intrinsic that will let us kind of go out the other end. Zig documentation. Saturating shift left. So I don't know. See also shift exact and shift with overflow. So I don't know what if this, okay, he says shift this by 8, we get 255. And I think I want shift this by 8 and we get 0. I think is what I want, because I want it to get like pushed out the back. So you probably want shift with overflow. So result and possible overflow bit. The type of shift amount, blah, 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 blah. I'm pretty sure this is what we want. Pretty sure. Is there also like shift left modulo? No. Okay. So can we write like a little test? Pub function main. And if we just do like std debug print a number, which is like var x is a U64. And we want like x or equals, like as U64 1 shift left with overflow. I want to shift this by like const shift is a U7. And I want this to be, I guess, like, I'm thinking. I guess like the normal shift does the overflow like I wanted actually. Because you should never shift by, like 64 should never happen actually. Because a shift of 64 just means like 0. Just like there's nothing of value in here. So 63 is the max shift. And so we want to see what happens if we do like x equals x shifted left by shift. This should just give us 2 to the power of 63. So there's actually nothing that we have to do here, actually. I'm pretty sure. We might as well run this test since we wrote it. I was confused about the overflow thing. I was confused. Okay, so can we do like zig run test.zig? What? Oh, it's test2.zig. That's not helpful. Let's also print 2 to the power of 63. I don't know if that exists in this language. No. Stood math pow. U64 2 to the power of 63. Here's what we want. He's mad because there should be comma. Those are the same number. Okay. So everything is working the way I expect, I guess. So we go back to our protobuf parser. And here we don't have to change the type of shift. We don't have to change the operation. I have a quick question with what the hell is a U7? Does Zig have any size? Yeah, so Zig kind of has the ability to use any type of like U blank, I think from like 0 to 64 or something, or 1 to 64, maybe higher, I'm not sure. It surely doesn't support every single bit width, I assume. Maybe it does, but I would assume it doesn't. And your U6 up to U65535, that's crazy. That's a big, I guess that makes sense. I mean, why not? If you programmatically parse it, it's just, wow, it's surprising. So it'll represent like a U6 as a U8, mostly. But you have like some added like type checking constraints on there, which are pretty nice. And then you can also pack them, right? So if you have an array of U6s, that will typically be an array of U8, unless you like, there's a way to like use them in packed structs and stuff so that they kind of pack nicely. I just can't remember what the syntax for that is. I don't remember if you can do like packed arrays or only packed structs. Okay, so here we just have to make sure that like if shift. So what was this shit I was talking about before? 7777771. I guess it was just that the upper bits of this last component will get shifted out and it won't matter. So here we kind of have to say like, I think we still let shift get a little bigger so that this doesn't crash. And then we'll say this and shift is less than 64. Then here we can as use like int cast to a U6 of shift, because the Zig wants us to do like type safe shifting, right? You can't, like a U7 is too big. You can represent numbers that are unshiftable. And so that's why he wants us to be U6. I think this should be fine. We'll see if that fixes it. I'm not really sure. Now we just have a bunch of leakies, but I don't know if these leakies are coming after a crash. So we should just make sure that we stop leakies. Which means that wherever the fuck we were allocating our stop time updates, we just need to dinit on this thing. So this is a what? Trip update. This needs to take an allocator. And here we say self or alloc free each of these stop time updates. And does this thing need to be deinitted as well? This thing just does numbers, I think. Yeah, just event. Yeah, everything's just numbers. So we are chilling. And then here we just need to call trip update deinit. So here on feed entity, we need to say pub function deinit. And we say alloc. I guess we say if self trip update trip we do a little t dinit with our allocator. Boom. I don't know why he doesn't like this, probably because it's called trip update. And then somebody needs to call this. So feed entity must get denited somewhere, which comes from here. For entity, for self entities, we call e dinit with our allocator. Boom. No, really? Didn't we just make that dinit function? I mean, he must be wrong. We just made it. It's right here. He's mad about 250. No, so, oh, no, I don't understand. I don't understand. Oh, because it's supposed to say feed entity. I see. He's mad. He's a little mad boy. Are you using Emacs? Nope. Vim. NeoVim, specifically. But Emacs is pretty good. Emacs is pretty cool. I used Emacs for a while. Evil mode is pretty decent if you want your Vim bindings. It's a little... I eventually switched off because it was inconsistent. Right? Like, I found that, like, evil mode kind of worked in some cases, but not others. And so having to, like, figure out both, like, Emacs bindings and Vim bindings was too much for my stupid little brain. Isn't VS Code better for new programmers? I would recommend, yeah, if you came up to me and you said, I am going to start coding, what should I use? I would say VS Code. That's true. But if this guy's asking if I'm using Emacs, I was trying to more frame it as like, don't feel a need to switch editors if you're using Emacs and you're like, oh, I want to use what this guy's using. Like, I don't think it matters, you know? Like, Vim bindings are almost good enough in anything if you want to use them. And if you don't want to use them, that's also fine. I'm happy, you know, I use Vim bindings because I like them, but, you know, you don't need them. Okay, so we kind of got through the whole parse. And now we need to, we intentionally skipped some. I think it was here, these stop time events, because we didn't implement the signed variant parsing yet. Right. So let's look at stop time events. So I remember this being a problem where there's special encoding for signed integers and variants. And we didn't implement that the other day. So var int signed integers. Oh, these are just direct. How do I do base 128 variants? Here we go. Each byte in the variant is a continuation bit that signifies that the byte follows as part of the variant. The base is the most significant bit of the byte, blah, 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 like we were talking about already. I saw converting to big endian. Okay. These 7-bit payloads are in little endian order. How do they... I missed, there's somewhere like we saw something about like a trailing 1. I think it was in LEB 128. I think it said down here that protobufs use the same encoding, but by prepending the sign as the least significant bit of the first byte. So is there a reference to that? I don't see any like reference here, but maybe we can look at like varint. Signed. No. Least significant 3 bits. You can use varint to store any of the listed data types. Yeah, but like how? Signed varint protobuf. That's not what I want. Signed variant. Oh, like I just feel like it should be in here, but I just didn't see it. Message structure. So in their examples, they're using int32 here. So he must talk this, since this is signed, he must talk about it in some way. Each byte has a continuation bit. For example, here is a number 1. Encoded as 01. Here's number 150, encoded at 9601, which is what we saw here. So here he's just saying interpret as an unsigned 64-bit integer. But what? But like, this is signed 32-bit. So what the fuck? You know? I saw protocol, blah, 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 wire type 0, however, varants are unsigned. So different sign types, here we go, encode negative integers differently. The int n types encode numbers as two, okay, so I just like started reading this and then immediately scrolled away and it was exactly what I wanted. That unsigned 64-bit integers, they have their highest bit set. As a result, this means that all 10 bytes must be used. For example, -2 is this. This is the 2's complement of 2 defined as by this directly, blah, blah, blah. Sint n uses the zigzag encoding instead of 2's complement because 2's, yeah, that makes sense. Positive integers p are encoded as 2 times p, while negative integers are encoded as 2 times n minus 1. Got it. Got it. So here it's like if the last bit is set, you shift right everything and flip the negative, I think is what he's saying. In other words, each value n is encoded using this. So just reverse this, right? So you shift right by 1. Yeah, so they're just moving the sign bit down to the bottom by doing this. Right, okay, yeah. Simple. So here, if we go back into protobuf parser, and we have like our as buff, we just have another one. We can just like as I32. He's gonna be like, I better be a fucking varant. And then he's gonna say temp is equal to the varant thing. But if temp and first bit, temp is shifted right by 1. And we return negative temp. So here we probably want to like cast. We say like temp I32 is equal to std math cast of to an I32 of temp, or else we probably get angry in some way. If we shift right here, I don't know how like sign extension works. I assume zeros are shifted in, but I don't actually know. So we should double check that. So we can do like var x is a u64 is equal to std math max int u64. Let's x shift right equals 1. I assume this becomes, if we print this as hex, I assume that this becomes just like all ones except for the top bit, which should be a 0, but I don't actually know. How do I fucking hex print in this language? So the specifier has, x, it's colon x, is it not? Or is it before? Specifier, where does specifier come in? Argument specifier. Oh, D is decimal probably? Ah, it is, I see. So it's not D colon x, it's just x. That makes sense. Yeah, okay. So this is 7ffffff, which means that the thing that when we shift right, zeros are prepended, like I expected. But sometimes you just don't remember, which means that this is fine. And we say return error too big or something. Yeah, like value not int 32 or something. That's fine. We return negative temp I32 like this. Otherwise, we try to do this anyways, but we don't invert it. So it's just like this. Right. Chillin'. This needs to be shifted right equals. Then the var is justified and we're chilling. I guess you could do this, which I think is fair. Now, what happens if this is too large with a 1 at the front? right? If this is like 60 and then 32 bits of stuff, we'll kind of like shift to the right, and then this 1 will become like the sign bit, which is not what we want. So we kind of want to actually be like temp i32 and or 1 shifted left by 31. Is that right? I think so. That's 2 to the 32. Okay, so if I shift left right by 0, it's in the first 0th position. 1 is in the 1th position. And I want to get this into the 32nd position, so... Am I stupid? I think it's 31. Right? Because it's, I mean, we should just fucking check. I'm pretty sure. I can never fucking... off by 1s are so fucking hard. Yeah, we want 31. Because we want the top bit of a 32-bit, not the first bit of the next one. It's so hard sometimes. So this... I guess we actually can check if temp i32 shifted right by 31 is not equal to 0. Is probably what I want to check. We can say return error invalid i32 as well, or not int 32. I think is also fair here. All right. All right. So now I can go back to our wherever the fuck we were. We were probably trying to parse this trip update, stop time update, probably, and stop time event. This is where we were. So we had 1 goes to delay is equal to val data as i32. Boom. Chillin'. And then we have 2 goes to i64, which we also have to implement. This one should be easier. It's going to look very similar, except it doesn't need that check for the top bit being set. So this is the same shit, but this is now i64. Not int 64, not int 64, i64, temp i64. We don't need this check anymore because it's not possible. Then we're chilling. Then we are chilling. All right. And this is time, not delay. All right. So let's see what happens. He's mad because expected type bool. That's fair. If temp and 0x1 is equal to 1. You shift by 31 to get to 32, I guess, but I don't get the logic. You shifted 32-bit value to the right, got 31, the 32, most bit significance should be 0 by the test you did. I guess it's safe to do minus. Let me see if I can understand what you're asking. You're asking about this here? Right, okay. I'm kind of I was assuming 2's complement notation here. So the reason I'm shifting right by 31 here is because I wanted to check if the most significant bit was set after we shifted right by 1. Because if that's true, then we're going to end up with a negative sign at the we're going to end up with like this is going to already be the negative version of the number, which is like incorrect. And because this means that we had like we're expecting that the var int, right? So if you have like S32, your integer range is like -2 to the 31 to 2 to the 31. there's an extra value on one side. I can't remember which one. Probably, I think on the negative side. I can't remember. But it's like something along these lines. And so when we shift this U64 to the right by 1 and then cast it to an I32, it's possible that there's an extra bit in here, because the reason that this is true is because your like signed representation is like, if you have leading 1, right, then a bunch of stuff, like this is like kind of like your negative flag, kind of. There's like 2's complement is kind of like weird and confusing, where like there's like sign extension, so it's like if you have leading 1s, then it's negative. And so here I'm just checking that we didn't accidentally shift in a leading 1 when we didn't expect one, because we expect, like with the zigzag encoding, for it to be 31 bits plus a sign bit at the bottom. I don't know if I explained that very well. I don't feel like I understand it very well, but I think I got the point across. I think. Just got here. Are we working on zigzag encoding? Exactly. Okay, so here these things can be variable. And not int 32 is getting hit, which is interesting. This is coming from protobuf parser 118. Okay, wow. Can we maybe GDB, like, GDB args this, breakpoint in the failure case, hit run, and let's like just look at what we're looking at. Yeah, that's definitely not an int32, huh? Definitely not. Well, so like, what the fuck is going on here? We are a var int tag equals varint. So we did correctly decide that we are a varint, but the varint that we got is shit. I wonder why. It would be interesting to maybe print here in stop time event the buffer that we're trying to look at, and we can inspect it manually. Why? Okay, fine, whatever. Okay, up, p buff, px buff. So we want like this 11 times. So we have tag, then some shit. I mean, is it possible that this is... Yeah, what am I looking at here? So I guess we have to do some like little spelunking again. We see a tag followed by a value is like the first. This is what we're supposed to be parsing here. So we're trying to parse the stop. What was it? Where are we? We're in stop time event. So we are trying to parse this, and we're expecting to see a delay, time, uncertainty, and then some other shit. Okay? So we can now just poke and prod and see what we're getting. So we have the first thing. This says 8 shifted left by 3 is 1. So this is saying, hey, we are delay with wire type 0. So delay is represented as a varint, right? So then we look at this byte, and we look at 0xAE. P maybe as binary. 0, 1, 2, 3, 4, 5, 6, 7. So this is saying our delay value is in fact, I mean, as far as I understand the way that this is encoded, this seems correct to me, which is weird, right? If I say P0xAE and 1 shifted left by 7, that is set, right? Oh, maybe we have to do this. Right? So this is saying we have a sign extension bit on this. And then all of these are also sign extension bits. So I don't really understand. I don't understand how this is possible, right? Because we are, in fact, then this just gets like, we just keep going, right? And so this like FFFFFFFAE thing looks kind of right to me, not gonna lie. As far as I understand the format, this is the right number. So, what the fuck? Right? Let's go back to the signed thing. Little Indian versus Big Indian, perhaps? They say that they're supposed to be Little Indian. So, I don't think so. Where do they talk about signed here? So, sint_n uses the zigzag encoding. sint_n, right. I mean, this looks to me like it's just not a varant, right? This looks to me like this is like a fucking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I guess that is like 10 things. It just looks like it's 2's complement. It looks to me. Oh, the int_n. However, the varants are unsigned. So the different types, sint versus int or int encode. Oh, I misread this. I thought that it was always sint, but it's not. It's not. So we have, when we have varant, we have int32 or sint32. So if the protobuf says sint32, then it should be zigzag encoded. But it said int32, which means that it's just like wasting space. Okay, wait, I understand. So here these should be as zigzag I32 and as zigzag I64. But the int32 version, we can just say like as int32 is as simple as just fucking truncating and casting. Which is kind of funny. Right, it's funny that the int32 is actually represented, if I understand correctly, as a 64-bit number. That's just really fucking wacky. But it is what it is. So we're gonna say like, if we're not a varant, we have a fucking problem. But if we are a varant, then we say as U32 truncate this thing, and then bitcast it. And for I64, we don't have to do the truncate. We just do a bitcast. We don't need to GDB anymore, I don't think. Okay, so now the question, we looks like we've like parsed successfully. And now I want to compare with the right answer. You know, so let's go to our PB test, and we just want to look at maybe the times, right? So let's get tu trip dot Where's the time? It's TU stop time updates. For TU stop time updates, update. We will maybe print like a indented time and delay. We're gonna assume that they're set for now because I don't want to deal with it. And we will say arrival time or delay and arrival dot time. And we can just kind of see if these numbers line up. He's mad for some fucking reason. I actually don't know why. Cannot format optional without specifier. Oh, fine. Fine. We will assume these as well. And I guess we should new line these as well. And it does look like sometimes this is not set. So if arrival is equal to null, continue. U.arrival. Boom. Okay. So can we like less here? 2 and 1, so that standard error goes to standard output. Then we look for a got trip update. So this is the first thing. And we can do the same thing here. And we can just start trying to correlate. So 3, this is correct. We see negative 82, 102, 102. Then for the next one, we see 25, or negative 25 and 208. Negative 29 and 208, sorry. Negative 29, 208. We see 21 and 317. So it looks like this is working correctly. So I think we are chilling, and I think the only thing that we are missing now is we want the stop sequence as well. That's another important piece. So this is on the stop time update. We need the stop sequence. Oh, we have that. We have it, but we did. Oh, we do have it. All right, we're chilling. So we can just actually put the sequence in here as well. What is it? It's a U stop sequence. So is it got trip? All right, so 24, 24, 25, 26, 27, 28, 29. All right. Good enough for me. Good enough for me. I think that this is all of the relevant information that we want right now. So I think we don't actually have to do any calculation of how early or late the bus is because they fucking tell us. They fucking tell us in the delay. Okay. So I guess it might be interesting to... I guess like there's no real work here that needs to be done in terms of like correlating data, right? Because our representation on our map planner side is we have, we can actually just look. We can just look. Let's see. It's not easy to just look. But we can maybe draw it. So our representation is that we have like a bus stop and a bus stop. And we have like this trip that is like related to trip ID, like, you know, this is gonna be like trip ID 10, right? And we know, I think we have this information. I'm pretty sure, like, and then we have like another one, right? And this is from like TID 11. And this one is like TID 12, right? And each trip connection is unique. And so in our parsed data here, we have the trip ID as well as which stop in the trip ID. So we know that this is trip ID like sequence, sequence 4, right? And then this is like 10 seek 3. And then this is like 10-5, right? So we have like all of the individual sequence and stops. So we have that. And so now all we have to do is like correlate these, like no correlation. We just say, hey, this connection right here, we can like identify it correctly and say just tack on like a negative 82 second delay one time. And then we'll eventually have like a lot of data for these. And like maybe we will like, once we have more data, we can do something like curve it or like, we can maybe do like mean and STD or something and use these pieces of information to calculate like a consistency score or something like that. But for now, I don't think there's any more like real data to collect, which is pretty sick. Pretty sick. I think now let's try to get into like polling the HTTP server. I think that makes sense. So how do we want to do that? Let's see if Zig's HTTP client will work for us. I've seen in the past that its HTTPS implementation is not quite, it doesn't support everything. So if it doesn't work, then we're going to need to do something else. But for now, let's just kind of see what happens if we just, I guess all this goes away and we're going to do even this. I guess we'll just do like an if true return here. If true return. Okay. Then here, let's try to look at like std HTTP client. How do I like use this thing? Never used it. Well, I think I did, but I'm not enough to like have the API deep in my brain. Somebody said I can search Zig with bang Zig. They lied to me. They lied to me. Whoever said that is a dirty, dirty liar. Can we just do like this? And look at HTTP client. Here we go. Connect. All of these things take a client already, like as the first argument. So how do I make one of these things? How do I make a client? What the fuck? I'm confused. Right, like init default proxies? No, yeah, every single one of these takes in a client, so I don't understand. Does this just have, I guess I just create it with its allocator. And then, yeah, there's just no init function, I guess, which is fair. Then we create a connection given our host and port. Is this allowed to be a string? I assume it is. Right, this is a buffer. So I like if it expected an IP, I would assume that it's 4 bytes, not an arbitrary slice. But we can take a look. They call connect TCP. An ASCII comparison on host really indicates that it is the URL. But I'm kind of curious about just grepping a little more. Let's just see. Connect TCP. How does he use host? Find connection. That's fine. TCP connect to host. Which is a name. Yeah. Yep. Okay. Okay, I think we get it. So here we have allocator is equal to alloc. Boom. And then we want to connect to probably there's something at port 443. And we want to look at like translink GTFS RT. And I guess it's connect to host, right? is not like, then the connection we are going to call get on probably. No? HTTP client connection. How do I like fucking like write? Is there really no like function like get? Am I fucking stupid? Alec, write, fill, flush, peek, read, reader, redirect. Right, yeah, that's surprising. Surprising. Do they have no like post? Holy, how the fuck do they use this thing? How do they use this thing? That's crazy. Do they have no tests that I can compare with? No, like surprising. Proto. What does this do? This is like HTTP protocol stuff, I guess. That's fair. Request. HTTP request that has been sent. So send request headers to the server. Where does this come from? Read request. How do I like make one of these? Open. Open a connection to the host specified by URI. I see. So probably we fucking huck open with URI being like a leading slash thing. Probably. That would make sense to me. That makes sense to me. So here we want to like connect to this host, which is this. Right? Then we open. Nope. Try maybe. Unused local variable. This should... Oh, I'm missing some options here. Host, port, protocol. So this is TLS. Right. Then I have connection dot open. Was there not an open? Oh, it was client dot open maybe. Oh. I see. So this now becomes like kind of like the full URL. I think I get it now. Right, so we open a connection to this thing. The method is get. I don't know if it's all caps or not. It is. URI is URI, so it's actually this way. Then request options. And for now, I'm just going to default initialize this and see what happens. Okay, there we go. And this gives us a request back. Yeah. And then I assume that we want to call like wait. And then we can look at the response. I guess. I don't fucking know. We're just gonna look. URI. Where does like URI come from? URI parse this thing. Sure. Server header buffer is buff, I guess. And here we need like buff is a 496 U8 buffer. Cause he needs some shit to handle with. He needs some shit to work with, I guess. We'll call this HTTP buff because someone else is mad down there. Little angry guy. He's like, hey, I'm trying to use that. I'm trying to use that. Two-step being helpful with found an example. Fine, we'll look at the example. It's in, what's it? It's in http.test.zig. What the fuck am I looking at? Stood HTTP. Oh, is it not? I have to like go into the Zig source code for it, I guess. Lib stood HTTP test.zig. Here we go. Yeah. And it does look like they did almost the same thing. We forgot to write send, which it probably would have got mad at us for in a second. But other than that, it's pretty much the same. They read the body after, which also is kind of reasonable. That makes sense. But we'll figure it out. We'll figure it out. So we need to do rec send as well. And then I don't really understand what the fuck is like. Oh, probably because I piped into less like a fucking dumbass. That probably didn't help us out. With weird buffering. All right, we're in. Okay. So that's good. We got forbidden, which is good because I did give it an invalid API key. That is something that I did on purpose. So it looks like it answered, right? It's like, it's not like we're getting something that's like totally fucked, like it failed to communicate. It's just like, bitch, that's not right, which is great for us. That's great for us. There's probably some like defers that we have to do here. Right, probably have to do this. We probably have to do like this, probably. And we probably have to build before we run our code. You have to build the code if you want to run it. That's a classic mistake around here. Classic mistake. Okay, nobody's complaining. And now I think that we're just going to try to pass in the API key and hope to God that I don't leak it. Hope to God. Let's just double check now if the URL. I see no GTFS anywhere in this search, which makes me think that it never prints the URL. So we're probably fucking chilling. So we'll say API key is equal to API key. Here we're going to have to do some sort of like argument parsing to get that. So we're gonna have API key as a const q8. We're gonna say that like, wow, args next. We have some arg. We are going to say like switch stood. We're gonna like get an option, I guess. An enum, and our options are now gonna be like protobuf that we're testing with, I guess, and API key, I guess. If we have, we're gonna do like opt is stood meta string to enum. We're trying to get this into an option. We're looking at this argument. And if we don't get one, is this a failable thing or a optional thing? An optional thing. I'd rather use mvars. argv is a little bit easier to leak via htop or shell history. I was going to do it with cat arg, but I do see why that could be a problem. I agree. I think you're right. So we can do like, what is it? Stood process env get env map sounds right. Get envvar owned. I guess get env map seems fine. var env map equals to this. Defer env map dinit. No? Really? What happens then? Oh, we'll probably have to try this. And then we can dinit this, probably. Yep. Env map.get. We'll call this like translink API key. I guess if I ran env to look at my environment, I would get fucked, like you're saying. I just realized that. But yeah, which one do I think is more likely? I think it's way more likely that I'm going to leak through environment variables, actually. I type env a lot to look at Nick's stuff. So I think I'm gonna go back doing it this way. I'm gonna skip proper parsing here, I think. It's just kind of easier. So we'll say API key is this, API key is API key, and then that makes it really easy. That makes it really easy, because then we can then go in here and we say this gets appended with this. So we'll say const URL is equal to this, but stood format alloc print allocator this and args.api key. We try this, we defer URL dinit. Nope, alloc free URL. Then this guy has to pass in the URL here. And then this is going to be like, bitch, you need to give me your API key. He's actually not going to say that because I fucking can't compile ever because I forgot to write this. Paranoia mode if the service supports a new key for the stream. Yeah, I think that if I remember correctly, it wasn't straightforward to get a key, like trivially easy. But it's fine. It's fine. Okay, what did they respond in this case? HTTP status okay. So we're chilling. We're super chilling. I was reading pre-stream that we have a limit of 1,000 requests per day, so we're gonna have to be a little bit careful here. But I mean that's totally fine. So we actually just don't want the GTFS position one. We want the trips one. GTFS real time is the one we actually want. And I guess we just kind of run this in a loop. Seems reasonable. So it's almost like this should just be its own thing. So we'll call this like a translink fetcher. And we'll go over there. But get rid of anything related to like protobuf parsing. And this just becomes like translink parser const allocators equals stood mem allocator. We don't look at the protobus now, and then this is literally just API key. And we just kind of do this in a loop. We do this in a loop. Also, fuck everything below here. Boom. Boom, 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 boom. And we just have to do the actual work of writing out the thing. New chamber. New chamber. I'm down to take a little peek. Oh, that's so sick. Wait, that's so good. Yeah, that's awesome. I'm gonna take a look at it off after stream because I just want to double check the like save load stuff and stuff before I accept it. I've had a couple problems with that in the past, but that's pretty fucking sick. Pretty sick. Thank you for the submission. Exciting. Okay. Okay. So what am I doing here? I'm just gonna do like rec read all, I guess, into some buffer. I guess we're trying to basically pipe this stuff into a file. So we can do like output file is like a stood fs create some like create file relative to our working directory. Let's think about this. I guess we will just write it down as like a sequence number, I guess. So here we're gonna have like an output directory that we're trying to write to. And every file that we get will just get pumped into this output directory as like the next one. So we're gonna do like output dir is this. Here we write API key and output dir. Okay. Then here we just do like, why is it integer like this? So I guess we're just gonna, for now, do like index file index is equal to 0. And here we should say fix me, check existing files. So for now, maybe we'll say support resuming. But before we do that, we'll just kind of say like we are going to try to create the output directory, and if it exists, then we'll bail out. New here, what was that chamber submission? So on the right here, this is what we were calling a collaborative Rube Goldberg machine. And if you go to spheriphoria.dev, you will go to this website, it will tell you all about it. So the idea is that each chamber in here is its own WebAssembly module. The WebAssembly module is responsible for both physics, like applying impulses to the balls as necessary, changing their velocities and positions, and drawing to the screen. So if you want to try adding one, you can write a little WebAssembly module, compile it with the right APIs, upload it, and then it's likely that I will accept it. And it will be part of this animation on the right side of the screen. Okay. Well, it's cool. Yeah, it was a really fun project, actually. I learned a lot doing it. Like, a lot. So it's pretty fun. Pretty fun. So here we're going to make, like, an output dir. So I guess we're going to start with, like, std fs current working directory. We want to like make dir, and we're going to try to make it in args output dir, right? And if this fails, because the file already exists, then we have a problem. Nice. And does this give us back the directory? No. So then we have like std fs open dir, current working directory open dir of args output dir. This should succeed because this happened. And then down here we just say output dir create file of file index.pb essentially, right? So we want to do like this. This has to be like buff print somewhere. So we're gonna say like var file name buff is gonna be like, I don't know, like 100 U8s. If we need more than this, and we're in like it's fucking disaster territory. Like 100 characters is insane. So that's fine. Std format buff print into this file name buff with this thing and the file index. Here we're gonna say var const file name is this, which means we can create the file with the file name, and I don't give a fuck arguments. And then we can like std, what is it, FIFO? There's like some like pump thing that you can do. So I think you can do like, give me some FIFO, like this, and then FIFO pump. No. What does init not do what I think it does? Init static. He returns a thing. Yeah, it seems like it should be fine. I remember there being like a pump in here. Yeah, so we should be able to go FIFO pump from the rec reader into the file name or the output file writer. I seem to remember this being how it works. And then here we need to then make sure that we're only doing this every once in a while. So let's maybe put like interval in seconds as a usize or something. And here we'll say we have like some interval s for second string, and then const interval seconds is std format parse int of a u64 from this interval string base 10. This is failable. And then here we can just kind of slap all this shit in here. So we have like the output dir is equal to output dir, and the interval s is equal to interval s. And then here, we just do like stood time sleep. I guess it kind of makes sense to do this at the bottom. Something. args.interval s times stood time ns per second. I think this sleep is in nanoseconds. Yep. And then we're chilling. Then we are chilling. Now, arguably, there's like error handling should be done here so that like the app doesn't close itself. In the case where, you know, the service temporarily goes down, we shouldn't just crash in that case. But maybe it's okay to crash there and have systemd. Like if I have this thing set up as a systemd unit, then that will indicate to me that it's a problem, and maybe I'll take like user action in some case there. I have like this little like square in the bottom right of my screen on my main account that tells me if any systemd units have failed. So it feels like that might make more sense. I don't know. We'll think about it. We will think about it. But if everything is right here, I guess our help should then say interval as well. Let's try like grabbing some data at like a 5-second interval. Is there a debug print in here? Yeah, fuck this debug print. So I guess we need to build this, huh? Which we don't do right now. Build zig. So we actually need like, this is going to be our pb test exe, make exe, and we'll give it like a source, which is going to be a this and a name. And we're just kind of going to do all of this stuff in here. This is going to be from name. This is going to be bpath source. And I'm going to put kind of like var target is like, I'm going to put these things in like a global space. I don't have to pass them around because I'm a fucking lazy piece of shit. So this goes here. This goes here. Something like this. I don't know. Like this, then these get like this, and then here we don't have to freak out. Check step also needs to go here. I guess really we should do something better, like a little class or something, but I will do that in the future. Cause, you know, shut the fuck up. All right, so then this becomes make exe of b source pb test zig and pb test, and now we have a new executable that was whatever the fuck else we were working on. What was this, like translink fetcher? All right, build check. He's mad because I guess this can return a failure, which means that these guys have to be tried. Fair, fair, fair. This guy, he's always like whining about me following the rules of the language and stuff. Translink fetcher not found. Did I spell it wrong? Translink. Translink. Much better. Much better. So he expected, okay, there. We're getting into failures here now. So this is not try, it's try. That's a good point. File index is never incremented, which is a fucking problem. So here we want defer file idx plus equals 1, I guess. Here he wants this to have some options. And then maybe we're chilling. No, sub path. Expected constant rate found, no space left. So 77. This is a try. That makes sense. Error, no space left. It's 77. Oh, it's this as well. That needs a try. And then I guess like fix me. Maybe we should loop if here, but like in reality, having 100 digits is a fucking disaster, and we should never make it that far if our polling rate is anything reasonable. He's mad at 77 that I did not wrap this thing in a structure because there are no variadic arguments in this language. He just needs a struct with fields to iterate. And it looks like we should be able to try running this thing now. So this is translink fetcher. He wants the API key. He wants the outputter. So samples, we'll call it, and an interval every 5 seconds. And let's see if we get something there. 0 PB, 1 PB, 2 PB. All right, and we can then check if we can process those things. So we can go back to our PB test Zig and get rid of anything here not related to the protobuf. So this is PB, API key, get the fuck out of here, API key, get the fuck out of here. This doesn't need an API key anymore, so we can do that, and none of this HTTP shit. All of you go away. Okay. And so we should be able to run PB test on each of those things. So samples 1. Yeah. Pretty sick. Pretty sick. So we are now getting data over time. And the question is now, what do I want to do next? So our options are, we can try to like process this data, but I think that I don't want to try processing it until there's like more of it. We know that we're gonna have to do something like in this PB test. Oopsie, what did I just do? In this like PB test app, instead of just printing stuff, what we're gonna want to do is we're going to like probably do something that's like for each day, maybe like for each update, update trip, update map of like trip, stop sequence to delay. And here we're gonna say like the rules are gonna be like overwrite if timestamp of update is newer on same day, right? Because the same trip is going to be used like multiple times across multiple days. And then that's kind of it, right? That's kind of it. Is we're going to like look at this stuff, and then we're going to do like, maybe we want this to be like this, like an array of delays, and then we're going to say like calculate average like stood and mean of delay times, and like export for consumption in transit planner, right? But I think it's reasonable to me for now to kind of say that we can handle that when we have a large amount of data, or like large is strong, when we have more data that we can work with. Like it makes sense for me to me to do this when we have the data, if that makes sense, because then we have like stuff to test with. So I'll probably run it overnight, in which case if I want to run it overnight, it seems like hooking this up to like my system in some way that I don't have to like monitor so closely would be nice. So I'm kind of interested in kind of making this like a systemd unit, which I can never remember how to do. But basically then I can just hook it up to somewhere where it's gonna like output to somewhere, and then we can chill. So what does it say? Restart always, restart sec. How is there like just like a man page I can look at? Man systemd unit, man systemd service, systemd unit man page. I'm pretty sure it's systemd.unit. Of course. That's a lot of words. Examples. Here we go. Okay, so here you can say when you want it to run, essentially. here's like the executable that you're running. And then I saw in this like Arch wiki page that we were just looking at, there's like some sort of like rules on restart. So let's like restart sec. That's not in here. So they're just liars? Like, maybe? I don't fucking know. Restart equals. I just don't even see start limit interval seconds. Configure unit start rate limiting. Right, so this is probably important. We don't want it to like, if it crashes, we don't want it to like just spam reset. We want to make sure that we are not happening more than burst times within an interval. Time spans are not submitted to start anymore. Use start limit interval sec to configure the checking interval and start limit burst to configure how many starts per interval are allowed. Yeah, okay. So this we want. So let's do like a service translink monitor.service or something. And we're gonna want these. We're gonna want basically some example that's like a not a one shot. We want like something that's gonna restart. So this probably, and then where was that like the start limit? Oh, it's over here already. We have it open. Like, which section does this go? I assume that it goes under the service section. Unit section. Oh, all right. I was wrong. And I'm willing to admit that. I'm wrong sometimes. Can we like... Okay, fuck this window. Save this. This is translink monitor. And this is going to exec start home streamer work hello zig out bin this, and we need to give it some arguments. So we're gonna use like, I don't know how to like systemd we're gonna want like an interval of like what's our like, we have 1,000 requests per day, so we have like, how many seconds are there in a day? There are 24 hours times 60 minutes times 60 seconds divided by 1,000. So 86 seconds. We'll give it a little extra time just in case, so we'll say 90. We need the API key. So I don't know if you can like systemd file API key argument. I don't know. Somebody must have come across this before. Systemd argument from file content. Environment file script args. Does look like that they're allowing you to just fucking throw some variables in there. I don't want to like hard code the API key. I just want to like get it from some file. I guess I'll just for now do the like cat fuck this, and then we're gonna call this like API fake API key first, because I'm not convinced that this is gonna be right. So I want to try it once with the wrong thing, just so that we can see. We wanted start interval sec. This was going to be like 90. And the limit burst is going to be 1. And maybe this will work. I don't fucking know, man. We can try it. So let's make a fake API key here. And just call it like, you know, this. And then we can do like system CTL user install like install translink monitor service. That's how it works. No. Can we like install user service? Crap the whole thing in a shell script or load the file in a Zig program. Yeah, that seems reasonable. Just came back. We system D'ing now. Yeah, I'm just trying to figure out how to like. I want to like get this thing kind of just running all the time, you know? What about like user? No. How do I like install systemctl install user service? Like, do I need to just copy paste it into the fucking right directory and config, or can I? Yeah, I have to place it here. That's kind of lame. That's kind of lame. What was it? Config systemd user. It's already there. So can we like ln-s? Can we like ln-s work translink monitor, and then can we like systemctl user enable translink monitor or start systemctl user status. Can we look at like what happened? Translink monitor. Okay, so what happened? Invalid environment variable. Okay, so he doesn't like this cat here, which is what I was worried about. So can I systemd pass file content? This sounds like a ChatGPT thing. Systemctl. How do I write a systemctl unit file which does the equivalent of our cat file? It doesn't like this thing. Okay. Modify systemd unit file. I mean, what if I don't? Can I do it without the wrapper, question mark? Like, that's fine, I guess, but environment file. Yeah, both of those are things that I've seen. This seems most reasonable, huh? Just to fucking slap a bash-c in there. It's a little silly, but whatever. Good enough for now. Systemctl user daemon reload. Systemctl start, I guess, and status. So now he's just probably mad because it like executed reasonably with a complaint being like, can I like see how do I go backwards? -B, I think. Do I not get like standard error of that thing anywhere? It should fucking complain that it was wrong. System does it capture standard error by default, question mark? Viewing logs, okay. Translink. I already forgot what it's called. Journal ctl -u translink monitor.service. Nothing. Systemctl status. User status. You saw 203 somewhere? Status 203. But like I expected kind of like better errors than that. Is it because like did I fuck this up in some way? Did it even run? Yeah, what is status 203? Error 203. What does this mean? Unix, Linux exit code 203. What does it mean? Oh, probably because bash is not like isn't allowed to be a relative path. user, what is it? User bin env bash. How does this work? Right when you do like shebang, this tells you, is this not how you're supposed to do generic bullshit? But if I type a user bin env python 3, like, that does nothing. This does something. It's fine. We'll just do a witch bash for now. I don't want to deal with this fucking NixOS stuff. We'll try this for a second, and then we can always, you know, get a little better as we go. Daemon, reload, and start. Status. There we go. Status 1, failure, and he's mad that the arguments were wrong. Because I forgot the output directory. Nice. So I guess we will just say that the output directory is going to be home streamer work translink GTFS RT samples daemon reload restart or start. He's mad, surprisingly. What's he mad about this time? Start request repeated too quickly. Oh, because I have this fucking limit in here? Can we delete this for a second? Daemon, reload, start. Okay, status. Okay, he failed because I couldn't make the directory. That's good. Move samples back. Let's run them again. Okay. Good thing that I didn't write the real API key in here. Now, what I don't really understand is, shouldn't he fucking have failed because it's an invalid API key? Oh, we probably are just writing the fucking empty response pack into the file. That's pretty funny. That's pretty funny. Because he doesn't actually check if it's okay or not. Okay. Cool. So, I'm going to call it there. There's a lot of like error handling cleanup stuff to do here, so I need to make sure that like it correctly resumes. Like I need to make it so that it correctly resumes when the systemd unit restarts. I need to make it so that the correct API key is used. So we're gonna say like resume file output API key, correct API key. The systemd unit is gross, but I mean overall we're pretty much there. All right. So thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 Pacific time. If you're watching on YouTube, you're seeing the 2 to 4 segment. There's a 12:30 to 2 segment where we kind of do like less of the new feature development and more like cleanup, error handling, unit testing, debugging, that type of stuff. The past few days we've been working on some like pretty interesting Wayland debugging in that section. So if you want to see that, they're archived on Patreon, or you can swing by and check them out on Twitch. If you're on Twitch, there's a YouTube link in the Twitch description where you can see all of the stuff we've been working on. We're working on this map right now, but there's some other stuff in there if you want to check it out. QR code decoder, neural network, like operating system, file system, using Fuse, like everything we work on is, to me, interesting and hopefully to you interesting. So you can swing, like check those out if you want. GitHub link in the Twitch description. We'll have the code for this stuff eventually under the GTFS RT monitor repo or this FMAP repo, depending on like which side of the code you want to look at. Yeah, like, subscribe, Twitch Prime, you guys know the deal. And I think that's it. YouTube, goodbye, and Twitch, let's find someone to raid.